Welcome to our momentum lecture. This is the first of two. And to get these notes, you will need to get them, download them from this website, http://db.tt/IXOYYGHM, and all of these are lowercase. So today we're going to look at momentum and impulse. You can see P is equal to mv. So P is momentum, m is mass, and v is velocity. You can see the mass units and the velocity units have not changed since the kinematics section, but momentum has the units of kilograms meters per second. Impulse equals force times time. You might see a delta T in here, but we're not going to worry about that part. So force has not changed since the Newton's laws section, and T is time, and changed since kinematics, and impulse is a Newton second, which, believe it or not, is the same as a kilogram meter per second if you do the work on this. So let's look what we have here. I got a 1,200 kilogram vehicle, and let's just put our letters like we have been in the past, speeding down the highway at 25 meters per second, so we know that's a V, and see what is momentum. We go up here, so P equals mv. We're looking for the P. Please make your letters very plain. This is a lowercase p. The mass is 1,200, and the V is 25. And as we've done in the past, we're not doing the calculation, but we're looking for the units, and the units for momentum is a kilogram meter per second. Let's look at our next one. We have the mass here. Now, we may not need it, but it's good just to label everything. It says we have a force. Ooh, that helps. We have a time, and we want the impulse. Okay, we want the impulse, so I equals Ft. Okay, we're looking for the impulse right here. We have F, which is 25,000, and the T is 0.005. Now you notice by knowing our units, we didn't need the 1,200 kilograms. So I is equal to, and it's in Newton's second. I'm leaving these two for you, so let's kind of go to the next page. Okay, I have a 60 kilogram runner, so there's mass, hits the wall at 4.5, there's our V, and stops in seconds, and we want to know the force. Well, we didn't really have an equation with all of this in there. We don't have impulse, we don't have momentum, but if you know the impulse momentum theorem, that impulse equals momentum, and we, since A equals, so the impulse is Ft, and the momentum is mv. So we can use this one by just knowing that impulse and momentum are equivalent. So Ft equals mv. So it says we're looking for the force, and the T is time, and the mass is 60, and 4.5. Now, as we know, force will always be in newtons. And here's another one along the same lines. That there's our mass, there's the force, there's the time, but I want to know the V. So Ft equals mv, so I have a 35,000 force. The time is 0.98 seconds. That's a 900 kilogram car traveling at some velocity. So V is in meters per second, and know thy units works very well. So the rest are left to you. If you have any questions, feel free to contact me.